Hello, my dear students. How are you? Hope all of you are doing well and maintaining good health. I'm Dr. Smruti Rekha and I welcome you all to Etuson, Education for Better Tomorrow. It's a digital learning platform for Odia and English medium students. If you believe in quality education, then you are in the right platform. As in eTuition, we provide quality education which will definitely help you to build your career. Then what are you waiting for? Please download the eTuition app and enroll yourself so that you can avail all the facilities at your fingertips. So students, without wasting much time, let us start today's class. As you can see, today we are going to start with a new chapter, that is chapter 5 of your NCERT book, that is Arithmetic Progression. So today we will learn the concept of the arithmetic progression. So are you all ready for that? So let us start. So before understanding the concept, let us look at some patterns which occur in our day-to-day life. Some such examples are: suppose Rina applied for a job and got selected. She has been offered a job with a starting monthly salary of rupees 8,000 with an annual increment of rupees 500 in her salary. Her salary in rupees for the first, second, third year will be respectively how much it will be. First year it will be 8,000, second year 8,000 plus first year of annual increment, that is 500, that is 8,500, and third year it will be 9,000, so on and so forth. Correct? Now let us take one more example. The length of the rungs of a ladder decrease uniformly by 2 cm for bottom to top. The bottom rung is 45 cm in length, then the length of the first, second, third up to eighth rung from the bottom to the top are respectively how much it will be. Initially, if you have started with 45 cm, that is the bottom rung, the immediate next one will be 45 minus 2, that is 43 centimeter, correct? Then 43 minus 2, that is 41 centimeter. 41 minus 2, that is 39 centimeter. 39 minus 2, 37 centimeter. 37 minus 2, 35 centimeter. Then 33 centimeter. Then 31 centimeter. So on and so forth respectively. Right? So this is how you can find out subsequently how it is going to change, right? Let us take one more example. Suppose Sakila puts rupees 100. Sakila puts rupees 100 into her daughter's money box when she was 1 year old and increased the amount by rupees 50 every year. The amount of money in rupees in the box on the first, second, third, fourth birthday were how much in the birth she has got 100 years, that is 1 year, right? 1 year birthday. So she started saving the money, and in the first year she has put 100. Okay. Second year 100 plus 50, 150. Third year 150 plus 50, 200. 200 plus 50, 250. So likewise, every year she has increased the amount by 50 rupees as compared to the previous year. Correct or not? Okay. So what you are observing in all this pattern? So there is a subsequent change. There is a relationship existing between the preceding value and the succeeding value. Correct or not? Let us understand some more patterns by considering some number. So consider the following list of number, that is 1, 2, 3, 4. So in this, what is the difference between the subsequent number, that is 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 2 is 1. So each number If you compare, each number is one more than the previous number. Correct or not? Now, beat 2, 100, 70, 40, 10. So here, subsequently the numbers are decreasing, and it is decreasing by how much? Like, for example, here it is 70 minus 100. So it is decreasing by minus 30, right? It is decreasing by minus 30. So similarly, you see here 70 minus 100. How much? Minus 30. 40 minus 70. How much? Minus 30. 10 minus 40. How much? Minus 30. So here also you can see that subsequently the difference is same, and it maintaining the same relationship, the number, the progression of the series of number continues. Correct or not? Similarly, suppose consider the example which I have taken as bit 3, minus 3 minus 2 minus 1, then 0. Okay, so here what is the difference, common difference? It is plus 1. Correct or not? Similarly, compare here minus 1 minus minus 2, that is also plus 1. So here also the common difference is 1. What about the bit 4, which I have, where all the numbers are 0, are 3? So 3 minus 3 is equal to 0. 3 minus 3 is equal to 0. So here basically the relationship, every time number 0 is being added. And suppose consider bit 5, which I have taken here. So minus 1.5 minus minus 1.0. So what is the answer? So here it is minus 0.5, right? So similarly, you can check minus 2.0 minus minus 1.5. That is also minus 0.5. So here the numbers are decreasing by 0.5. Correct or not? So what you have observed in all these illustrations which we have taken, there exists a common relationship between the two consecutive numbers in the series. Okay, so either it is decreasing or increasing, but it maintains a common difference, and which holds good for the entire series of number that is provided to you. Correct or not? So from this, the concept of arithmetic progression can be understood. So progressively it is changing. Progressively the values are changing. So in all the lists above, we see that successive terms are obtained by adding a fixed number to the preceding terms. So when I am telling adding, so adding can be adding a positive number or adding a negative number also. Such list of numbers is said to be an arithmetic progression. In short, we tell it as AP. Arithmetic progression. In short, it is AP. Each of the number in the list is called a term. Okay. So an arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Correct? This fixed number is called the common difference of the AP. Right? Like for example, when it was 1, 2, 3, 4. Okay, so here 1, 2, 3, 4, 5, 6, these are each and every one is called term. Okay, what is difference? What is common difference? 2 minus 1, right? Let me write it so that it will be more understandable for you. So suppose you have 1, 2, 3, 4, 5. So here each and every term will be, every number here you have are terms. Okay, these are all terms. Okay, then what is common difference? 2 minus 1, 1. 3 minus 2, 1. So common difference is 1 here. Correct? And remember that it can be positive or negative, negative or 0 also. Correct? Okay. So now let us denote the first term of an AP by A1, second term by A2. Then the nth term will be denoted by A subscript n and the common difference by D. Then the AP becomes what? AP means arithmetic progression becomes A1, A2, A3 up to an till nth term, right? So if you want to find out the common difference, so how you are going to find out? It is like the succeeding number minus the preceding number. So A2 minus A1 will be equal to A3 minus A2 will be equal to A4 minus A3. So in that case, the last common difference, if you consider the nth term, it will be an minus 1, where n and n minus 1 are the last and last but not number, correct? So that gives your common difference, right? So here A plus D, A plus 2D, A plus 3D represents an arithmetic progression where A is the first term and D is the common difference. This is called the general form of an AP or arithmetic progression. When AP have only a finite number of terms, such an AP is called a finite AP. For example, the heights of some students of school standing in a queue in the morning assembly are 147, 148, 149 and up to 157. So here you can see here the series of number starts from 147 at it and it ends at 157. So beyond that there is no number. So there is a finite number of terms in this arithmetic progression. So you call it as finite AB. Let us take one more example. The balance money in rupees after paying 5% of the total loan of rupees 1000 every month is. So here 950, 900, 850, 800 up to 50. So here also the balance money, it cannot go beyond that, right? So this is also a finite arithmetic progression, correct? Now, if the arithmetic progression doesn't have a finite number of terms, then it is called infinite arithmetic progression. For example, if you remember, we have taken this example earlier where Rina has applied for a job and initially she was getting 8,000 rupees and she has been assured that from next year onwards she'll get annual increment. So each time it will be increased by 500 rupees. So it will be 8,500, 9,000, 9,500, then 10,000, so on and so forth. So it will continue unless and until Rina leaves his job. So we don't know when Rina is going to leave the job. So it is infinite arithmetic progressions. Correct? Suppose your list of natural number. There is no end to the list of natural number. Correct or no? So these are all examples of infinite arithmetic progression. Now let us take one example to understand. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2. Write the first term A and the common difference D. So as you can see, there is a series of number. So what is the first term? So each and every number is a term. So here we need to identify the first term. So first term is 3 by 2. And then we have to find out the common difference. So the common difference will be how much? 1 by 2 minus 3 by 2. Right? So your answer will be, your denominator will be 2. Okay. So you have 1 minus 3, that is equal to how much? That is minus 2 divided by 2, that is minus 1. Similarly, let us check with the next subsequent number, that is minus 1 by 2 minus 1 by 2. Right? So that taking minus common, you have 1 by 2 plus 1 by 2 and the answer is again minus 1. So what is your common difference then? So your common difference is equal to 1. Correct? Now let us take one more example to understand how to find out the common difference. The first term exactly, right? So which of the following list of the numbers form an AP? If they form an AP, write the next two terms. Okay, so let us take bit 1. So what is there in your list? It is 4, 10, 16, 22. So this will be in AP only when the common difference is same, right? So let us check. 10 minus 4, how much? It is 6. 16 minus 10, it is 6. 22 minus 16, it is 6. So here common difference is 6, right? So you can see that in every subsequent number, there is a difference of 6. Each number differ by 6 from its preceding number. Correct or not? So it is an AP. So the series represents an AP. Series represents AP. Series represents an AP, right? And what will be the next two numbers then? Then the next subsequent number will be, so it will be 22 plus 6, that is 28. 28 plus 6, that is 34. So I can write it here. So 28, comma 34. Next two number, right? 28 and 34 respectively. Similarly, let us go to bit 2. So in bit 2 you have 1, -1, -3, -5. Okay. Let us check the difference. -1, -1. What is the answer? -2. Similarly, -3, -1. What is the answer? Again -2. -5, -3. What is the answer? -2. So here common difference is how much? Common difference is -2. So this series represents AP, right? As there is a common difference of -2 in the series. So what will be the next two number then? So the next two two terms will be -7 and -9, right? -7 and -9, correct? So how I obtain this -7 and -9? That is nothing but equal to -5, right? -5 minus, right? It is -5 minus 2, right? So that is equal to -7, right? Similarly, -7 minus 2 equal to -9, right? Okay, very easy, right? Now let us go to the third bit, that is -2, 2, -2, 2, -2, 2. Let us check. So you have -2, 2, -2, 2, -2, 2. So now you check. So in the first one, it is the common difference is 2 minus -2, that is 4, right? In the second one, it is -2 minus -2 minus 2. What is the difference? It is -4. Again 2, 2 minus 2, right? So again 2 minus 2, it is 4, right? 2 minus -2. So here the common difference, alternatively it is changing 4 minus 4, 4. So this does not represent, so this does not, it's a pattern, but this does not represent AP. Correct or not? Can you express it in terms of A plus T? Is there a common difference? No, the difference keeps on changing. So this cannot be arithmetic progression, right? So next one is, so you have, the next one is 1, 1, 1, 2, 2, 2, 3, 3, 3, right? So here you see, here first three numbers, it remains same. Second three numbers, it remains same. Third three number, it remains same. So on and so forth. It can be a pattern. Okay, so every fourth number is a different one, and it is repeating thrice, right? But if you compare the common difference here, common difference in the series, first it is 1 minus 1 0. Second also it is 1 minus 1 equal to 0. Then again 2 minus 1 equal to 0. Then it becomes 2 minus 2 is equal, here 2 minus 1 equal to 1. 2 minus 2 equal to 0. So it keeps on changing, right? So there is no common difference, right? There is a pattern which is followed, but it doesn't satisfy the condition of your arithmetic progression, correct or not? So this does not represent arithmetic progression. Correct, children? Hope you have understood this. Thank you for your patient hearing. Hope you have understood the concept of arithmetic progression. If you have liked the video, please share with your friends. Subscribe our channel. Don't forget to download the Etuson app. Follow us in Instagram, YouTube, Twitter. Okay? And take care of yourself.